Welcome to video number 2. So today we're going to go over what is calculus, and then we're going to dive into limits and derivatives. So first of all, what is calculus useful for? Two big uses are evaluating area and slope. So as for area, if somebody gave you a random shape and asked you to find the shaded area, how do you do it? Well, you can get an approximation by dividing the shape into a number of rectangles and adding up the area of all of those rectangles. And if you increase the number of rectangles, then your approximation gets even closer to the actual area of the shape. And if you keep on increasing the number of rectangles to infinitely many, then your approximation becomes the exact area of the shape. And as for slope, you can't find the slope of nonlinear functions, but you can find the slope at a point of a nonlinear function. So let's say, for example, you want to find the slope at the point 2, 4 of the function y equals x squared. And to do that, you can start by picking a point to the right of 2, 4 and finding the slope between those 2 points. So for example, you can pick 3, 9 and find the slope between 3, 9 and 2, 4. And you can get even closer to the slope at the point 2, 4 by picking an even closer point and finding the slope between those 2 points. So for example, you can pick 2.5, 6.25 and find the slope. And you want to move the second point closer and closer to 2, 4 and find what the slope at the point approaches. But you can't exactly choose 2, 4 for the second point, because then you'll get 0 divided by 0, which is undefined. But with calculus, you can determine the slope at a point. All right, so now we're going to talk about limits. So first of all, how are limits written? Well, you see you have the 3 letters LIM, and then underneath you have X and an arrow pointing towards A, and then to the right, you have f of X. And now keep in mind that X could be another variable, but it has to be a variable. It can't be like a number. So it could be R, S, Q, and A, it can be either a number or a variable. All right, so what does this limit mean? It means what the value of f of X approaches as X gets closer and closer to A. All right, so what if we wanted to evaluate this limit right over here? What this limit means is as X gets closer and closer to 6, what does X plus 2 get closer and closer to? So the answer is 8, and you can determine that by just plugging in X equals 6. And that means that as X approaches 6, X plus 2 approaches 8. So this is an easy limit, but is it that easy for all limits? We'll see in the next few problems. So in this problem, use the graph of f of X to find the limit. And what this graph means is that if X is not equal to -8, then f of X is the value on the graph. So for example, if X equals -5, then it seems that f of X equals 2. But then if X is equal to -8, then f of X is equal to 9 rather than 7. So what do you think the limit as X approaches -8 of f of X equal to? Take a guess and then continue watching the video. All right, so the answer is 7, because remember that the limit means what f of X approaches as X gets closer and closer to -8. So for example, if we start at X equals -10 and then go up to -8, then f of X gets closer and closer to 7. All right, so in this problem, you cannot simply plug in X equals -8 because this function isn't continuous at X equals -8. There is an open dot at X equals -8. All right, and then here's another example of a problem where you cannot just plug in X equals 6, because if you do, then you'll get 0 divided by 0. But this limit still exists. So how do we solve it? The answer is to use algebra and simplify. So you can factor the numerator into x minus 2 times x minus 6. And then cross out the x minus 6 in the numerator and denominator, and then you'll have x minus 2. And then now you can plug in 6 for x, and then you'll get that the answer is 4. So knowing this process, I encourage you to pause and try this problem by yourself and keep watching the video. All right, so the answer is you first simplify by factoring the numerator to x plus 5 times x plus 8, and then you cancel these two out, and then now you get x plus 5, and you can plug in a negative 8 for x, and the answer is negative 3. All right, and then some limits do not exist, and there are some reasons for limits to not exist. There are 3 reasons. So the first reason is that there are multiple possible values or different results. So take a look at this graph. What is the limit as x approaches negative 9 of f of x? All right, this limit does not exist because if you start with the value lower than negative 9 and go up to negative 9, then f of x approaches 6. But if you start with the value higher than negative 9 and go down to negative 9, then f of x equals 3, approaches 3. And since you get 2 different results, this limit does not exist. And this limit does not exist either. It may seem originally that this limit would just be equal to 0 because you can plug in 0 for x, but we need to consider x approaching 0 from both sides. If x approaches 0 from above, then we do get 0 for the limit. However, if we start with a value lower than 0 and go up, then we don't get any answer because you can't take the square root of a negative number. You will not get a real number. And so you got 2 different results. The first is that the limit is equal to 0, and the second result is that the limit does not exist. And since you get 2 different results, this limit does not exist either. All right, but this limit does exist. So we just covered this problem in the previous slide, but then the only difference is that you see there's a negative sign in the top right corner of the negative 9. And what that negative sign means is that you must start with a value lower than negative 9 for x and then get higher and higher until you get to negative 9. So as we already covered, if you do that, f of x is going to approach 6. So this limit is equal to 6. And similarly, if you replace the minus sign with the plus sign, that means you must start with the value higher than negative 9 and go down to negative 9. And that means that the limit is equal to 3. All right, the second reason for limits to not exist is infinite limits. So take the example, the limit as x approaches 0 from the positive side of 1 over x. And you can see from this table that as you approach 0, f of x gets higher and higher, and eventually it's going to get to infinity. And infinity is not considered to be any particular value. So that means that this limit does not exist. And the same would be true if the limit approaches negative infinity. The third reason for a limit to not exist is if it doesn't approach any particular value. All right, so take for example this limit. Some of you might not know what sine means, but just take a look at the graph of the function and you'll see as x gets closer and closer to 0, the function moves increasingly quickly between 1 and negative 1. And if you zoom in, you can see that that is really the case. And so since f of x just moves increasingly quickly between negative 1 and 1, it doesn't approach any particular value. So therefore, this limit does not exist. All right, now we're diving into derivatives, which means the slope at a point. There are many ways to write derivatives. So the first way is f prime of x. The second way is dy over dx. The third way is d over dx of f of x. The fourth way is d of f of x over dx. And keep in mind that d means delta in general. And these last 3 ways are pretty similar. So this is actually not that difficult to remember. All right, so remember that the derivative means slope at a point. So knowing that, try to find the derivatives of these functions. So I encourage you to pause, and when you're ready, keep watching the video. All right, so the answer, so since derivative means slope at a point, and these are all linear functions. So for f of x equals 7x, the slope is just always equal to 7. So f prime of x equals 7. And for these last two, they're just horizontal lines with a slope of 0. So f prime of x equals 0. And for this function, the slope is m. So f prime of x is equal to m. All right, and now here is the formula for derivatives. So suppose you want to find the derivative of f of x at x comma f of x. So you want to find the slope at the point x comma f of x. In this diagram, that's this point right over here. And your second point is x plus h comma f of x plus h, where h is a random number. All right. And then since slope is just rise over run, you can see in this diagram that the slope is equal to f of x plus h minus f of x all over h. All right, and you want x plus h to get closer and closer to x, because remember, you want the second point to get closer to the first point. And this is equivalent to h getting closer and closer to 0, but you can't quite plug in 0 because then you'll get 0 divided by 0. So this is where limits come in, because remember that this limit means as x gets close, or sorry, as h gets closer and closer to 0, what does this approach? So this is the formula for derivatives. All right, so how do we use this formula? So if you want to calculate the derivative of f of x equals x squared, here's what you do. So first you determine f of x plus h and f of x. You know that f of x is equal to x squared, they gave you that. So that means that f of x plus h is equal to the quantity x plus h squared. And then you plug those values into your formula. All right, and then after simplifying a little bit, you'll get to the limit as h approaches 0 of 2x plus h. And now you can plug in 0 for h, and then you'll get f prime of x equals 2x. And that is the derivative of x squared. So what does this mean? It means that if you want to find the slope at a point 3, 9, for example, you just plug in the x coordinate into 2x. So that means that the slope at the point 3, 9 is equal to 6. And similarly, the slope at the point 1, 1, you just plug in x equals 1 is 2. And instead of just imagining it, I want you to actually see it. So we have the function f(x squared graphed here. And so let's zoom into 1, 1. That's the point that we want to find the slope at the point of. And you see, as we zoom in closer and closer, we get closer and closer to a straight line. And the slope of this line is equal to 2. As you see, if you move 1 square to the right, you move 2 squares up. All right, and then now, given the formula for derivatives, try to solve this derivative by yourself. So pause the video if you want to give this a try, and then keep watching when you're finished. All right, so the answer is you first determine f of x and f of x plus h. You already know that f of x equals x cubed, and f of x plus h is just equal to x plus h cubed. And then you just simplify, you'll get to this eventually. And then if you just plug in h equals 0, you'll get that the derivative of x cubed is equal to 3x squared. And as a fun fact, the derivative of x to the power of n is equal to n times x to the power of n minus 1. And this works for x squared and x cubed. And this actually works for all values of n, even if n is not a whole number. So knowing that, try to find the derivatives of these two functions. So if you want to give this problem a try, then pause the video right here. All right, so the answer is, for the first one, 1 over x is the same as x to the power of -1. And using the formula, you determine that f prime of x equals -1 over x squared. And then the square root of x is the same as x to the power of 1/2. And using the formula, you determine that f prime of x equals 1/2 times the square root of x. All right, so here's a summary of today's video. So the important concepts that you need to remember, first you need to remember what limits mean, and then you need to remember evaluating limits given an expression. So how to use algebra to simplify the expression and then solve. And then non-existent limits, the most important part is you need to remember what the plus and the minus sign at the top right corner of in the limit as x approaches a, you need to remember what the plus and minus at the top right corner of a mean. All right, and as for derivatives, you need to remember what the derivative means and the derivative of x to the power of n. All right, and that's basically it for this video. So in the next few videos, we're going to continue learning about limits and derivatives. And before next video, you should know the following concepts. And I'm going to make the first supplemental video on these concepts, and I'll link it in the description.